Here's problem 2615. In the figure, if VA minus VB is 22 volts, how much energy is stored in the 50 microfarad capacitor? By having a potential difference between A and B of 22 volts, it would almost be the same as if we were to connect a battery of 22 volts between these 2 points. That's our potential difference between point A and point B. So we have 22 volts across the series combination of the 25 microfarads, the 50 microfarads, and the 25 microfarads. Okay, we want to find the energy stored in the 50 microfarad capacitor. Now our formula for energy looks like this. It's 1/2 Q times V, or 1/2 CV squared, or 1/2 Q squared over C. Either one of these 3 forms will work to find energy, and in particular, if we want to find the energy in a particular capacitor, we would want to know its voltage or its charge, because then if we know its capacitance, we can calculate the energy stored. So we want to find either the voltage across this 50 microfarads, or we want to find the charge stored on the 50 microfarads. Now, in this sense, one way we could find what we need to know is by finding the equivalent circuit and then finding the charge on the equivalent capacitance, because we know that the charge on series capacitors is equal to the charge on their equivalent capacitance, representing the series combination. So that would give us the charge, and hence we could figure out the energy. So we're going to go that way. So we're going to figure out the equivalent capacitance of this series combination of 3. Alright, so I'm going to have that 1 over C equivalent is going to be equal to 1 over 25 plus 1 over 50 plus 1 over 25. So that's going to be equal to 2/50ths over plus 1/50th plus 2/50ths, which would be 5/50ths, or 1/10. So C equivalent will be equal to 10 microfarads if I flip both sides of this result. So now our circuit looks like this: 22 volt battery and 1 C equivalent equal to 10 microfarads. Alright, well, the charge on that C equivalent is equal to the C equivalent times its voltage. And we know there's 22 volts across it, so that would be equal to 10 times 22, or 220 microcoulombs. So we have 220 microcoulombs across the equivalent capacitance, but we know that capacitors in series have the same charge, and they have the same charge as their series capacitance. So the charge on the 50 microfarads is going to be equal to the charge on the equivalent, is going to be equal to 220 microcoulombs. Hence, we can now calculate the potential energy on the 50 microfarads, and that's going to be equal to its charge squared over 2 times its capacitance, which would be 220 microcoulombs squared over 2 times 50 microfarads. And what is that equal to? 220 squared divided by 100 is 484. Now I'm going to have a micro squared over a micro, so that's going to be, one of the micros is going to cancel out, so this is going to end up 484 microjoules. Or if I wish to write that, I can say it's 0.484 millijoules. So that is the energy stored on the 50 microfarad capacitor by using simplifying the circuit, find the charge on the series combination, and using that charge to figure out the energy. So that's our answer.